Okay, I'm going to summarize what this basically means. All eyes on the board. For it to be continuous, following must happen. The limit from the left and the right must approach the same number. So let's write out, it must approach the same y value. And the y value, I'm going to define that as f of x. And that was covered in 1.4a. Yes? Left and right, agreed. And then the point must exist. This is a point. That is not a limit. So point exists.
Just any point?
To that specific x value that it's getting to. We'll do an example, okay? And then the point and the limit must be the same. So here's the idea. Let's say I have a graph like this, and I have a point. So Delaney, that's the point I'm talking about, okay? So let's say from the left and from the right, I come to a common point. That's condition 1. And that point is not an open circle is what they're saying. It must be a solid. And those two values must be the same is what this is saying. That's it, okay? So let's actually apply this. Let's see. Tim, let's read the question above A, B, and C.
Why are the following functions not continuous at x equals c?
Okay, we're going to look at condition 1, 2, and 3. So for this one, we know. Let's write out condition 1. From my left and my right, are we coming to a common point? Are we approaching the same point? So we know I'm going to say check. Second condition says the point must exist. If that's an open circle, is that considered that we have a point that is shaded? So we know automatically, for that reason, it is not continuous. And the second it's not continuous, you just stop proving. Okay? The next one, let's write condition 1. We're approaching C again. So from the left and the right, are we approaching the same number? No. So automatically, no, I don't need to go on any further. The next one, condition 1. From the left and the right, are we coming to a common point? Yes. So check. And then step 2 says, well, is there a point at C? Yes. Does that point exist? Yeah, it does exist, but it's not within the line. So step 3 would be no. So I give you 3 scenarios. So let's actually do them algebraically. Let's go ahead and write on here, when something is less than is my left, when something is greater than is my right. And I need to know if it's continuous or not. And we have to take the following steps, the 3 steps, very strictly. So let's write step number 1. The limit is approaching 1, but we have to first look at what is it from the left and the right. So f of x. So my left is a top function, so I want to plug in the 1 into my top function. So we have 1 all cubed plus 1. What would that simplify to? 2. Okay. Now let's test the right side. Limit. Holland, are you still on that thing that I think it is? Close it. Now let's look at the right side. The right side is my second piecewise. So when I plug it in, I get 1 plus 1. What do I get? 2. So then, here's our funnel. I gave you my left and I gave you my right. So you want to go ahead and put them together on this one. So in general, my limit as x approaches 1, not from the left or the right, of the function, it is 2. So that's my conclusion for the first step. Second step says, well, what about when it equals 1? Which piecewise tells us to use the one that's equal to 1? Top or the bottom? The bottom, so let's plug it in. We have 1 plus 1 is equal to what? 2. So we know the limit and the point does exist. So our third step is going to be the following. Step 3. The limit that x is approaching is the same as a point. So here's our conclusion. If this were to be a free response question on your AP test, which does happen pretty often, we want all the steps. Write more than you need. Over-explain. So we know, do we all remember 3 dots from geometry, if y'all remember? Therefore, it means in conclusion. So therefore, I would say, I would reword out this right here. Just copy that as it is. So therefore, f of x is continuous at x equals 1. And if you want to kind of write on here, in case you forget, this means therefore. Does therefore have O-R-E, I think? Did I spell that right? Therefore? Okay. So it is very strict. Test the left, test the right. Is it a common point? And then test the point itself. Should be common. Then the limit exists. Good? Okay. Let's do the next one that's got a rational function. First on this one, automatically, what should we do to this one? Plug it in. Everybody plug it in. I don't want to plug it in. And notice this is not a piecewise function, so we don't care about the left and the right. We're going to worry about this function itself. Do we all get 0 over 0? Yeah. So we need to do more. And typically that means factor. So step 1, limit as x approaches the 2 of f of x. Okay, how would I factor out the numerator? X something and x something. Someone said plus 2 and minus 5. Well, should it be plus 2? It should be the other way around. Ooh. Minus 2, but the minus 5 is good? Friday brain. Minus. And that would make sense because something has to cross out. So could I eliminate something? Once I eliminate, do I have to keep writing the limit notation? When you plug it in, you don't have to. So I'm going to put on here, we have 2 minus 5. How many is that? Negative 3. And then we have step 2. I need to know if f of 2 exists. Didn't we already, or if I were to plug in f of 2, plug it into the top and the bottom.
That's what we just did.
Yeah, we did, right? So it was 0. And 0 over 0 means we have a hole at that point. So that means it does not exist. And in case you're a visual learner, this graph looks something like this, and there's an open circle. So here's our conclusion. Clearly we know does not exist and negative 3 are not the same, right? So you would write out the following. The limit as x approaches the 2 of the function is not equivalent to the point f of 2. So then we want to kind of over-explain. We are going to say this statement, but instead of saying it is continuous, we're going to use what word right before? It is not. So f of x is not continuous at x equals 2. Always restate the question. So now let's look at an actual AP question that was done in the past. So if you're ready to move on, give me a thumbs up. And I'm going to throw some trig in here, but still show every single step. Michael, let's read number 3. Let f.
Let f be a function defined by f of x. I'm going to read the whole thing out. 1 minus 2 sine x for x greater than 0, and then e minus 4x for x less than 0. Show that f is continuous at x equals 0.
So it was less than for top and then greater than on the bottom, right? So less than means it's the left. Greater must be the right side. So let's go with step 1. Step 1. What is my x value approaching? 0. So let's write out limit as x goes to 0 from the left. My left is a top function. Is that sign scaring you a little bit? It'll be the simple one. 1 minus 2, sine of 0. And I want to worry about this guy right here. Sine of 0. Let's go ahead and draw our quadrant. This is 0. And that order pair is 1, 0. Is sine my opposite movement or adjacent movement? Opposite. That means it is 0. So if all that is 0, what would this value approach? -1 or +1? 1 minus 2 times the 0. It should approach 1. Is everyone okay with that? Because 2 times 0 is 0. 1 minus 0 is 1. Now let's go from the right side. Limit as x goes to the 0 from the right side of the function. So we're using the e to the x this time. E to the power of negative 4 times 0. So isn't that e to the power of 0? Any number to the power of 0, if you remember, is what? 1. So are we happy with that? Most definitely. So we know in general, as x approaches 0 from f of x, is 1. So my hope is that the point does also exist at 1. So step 2. We need to find f of 0. Which one can we use, top or the bottom? Top has equal to. So we have 1 minus 2 times sine of 0, which we kind of found already, right? How many was that? 1. So if you end up repeating the expression, that's fine. And that should be the case. So we know this guy right here is matching this guy right here. The limit that it's approaching is the same value as the point. So step 3. So we know the limit as x approaches 0 of f of x and the point of f of 0 are equivalent. What was the symbolic notation for it, therefore?
3 dots.
3 dots. And I'm going to underline the piece we're going to copy. You always restate the question or the statement. So we know that f is continuous. You could say f of x at x equals 0. So are we good on that? Test the left and right and the point. If they meet, they do exist. It is continuous. So I want to go ahead and skip to the next page. And that will be the last one for this notes. Let's look at number 8. How many piecewise is given? 3 of them. So I'm trying to figure out, and I'm going to give you a visual of this in a little bit. We're trying to figure out, is it, where is it discontinuous? Find all the values. Oh, right here. The fact that it's saying it is discontinuous, we know something's not going to equal to another. Okay? So let's kind of see. I want to color coordinate this. I want you to circle the 0 and this 0. And then I want you to circle this 1 and that 1. That means the ones I have in pink, I need to let them equal to each other. Because if they are equal to each other, the open circle has now been shaded in. Okay? So let's do that. When I plug in 0 to the top, we have 0 plus 1. Now plug in 0 to the middle one, e to the power of 0. What does my right give me? What does my left give me? And then the right is also 1. So are we good with that? Yes. So we know just for that piece, it is continuous at x equals 0. Okay. So then, let's look at the other piece, the 1 to 1. So I'm going to plug in 1 to the middle function, e to the power of 1, must equal the bottom one, 2 minus the 1. Isn't e to the power of 1 just itself? Okay. What is 2 minus 1? Does e actually represent 1? Isn't like 2.7 something, something, something? So we know this 1 is not equivalent. So I'm going to say it is not continuous at x equals 0. So here's a visual that's not perfect, if you're a visual person. I have a line, and I have a solid circle, and I have some exponential, and then I have an open circle, and here's my third piecewise. So we know it is continuous here, but I need to pick up my pen and continue to draw. And that's what this is representing. Good? So right here, not continuous, and right there it is continuous. Just a visual.